guys, welcome back to the Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. Today our lecture is to analyze this simple frame. You can see here this is a frame consisting of one beam and the two columns on each side, and they are supported, the columns are supported by the roller and hinge support. So I will analyze this frame and will find support reactions, the shear force and bending moment diagram of this frame. The frame is given to us, the beam length is 20 foot, each column length is 10 foot, and the load on the beam is 2 kg per foot, is a uniformly distributed load, while the lateral load on the column is 20 kg acting at the center of the beam. So when it acts at the center of the beam, so this distance will be 5 foot, because 10 foot is the total distance. So if it is at the center, so the 5 foot will be the distance from the center of the column to the end of the column. So first of all, to start analysis, first of all I will find its support reactions. So let's consider this is point A and this is point B. So the roller support have only the vertical reaction, as you know. So this reaction will be called as RA, only acting in the vertical direction. There is no horizontal reaction from the roller support. While the hinge support have two types of the reactions, one is horizontal and one is vertical. So I can write it here, the RBY in the y direction. Similarly, the horizontal will be RB in the x direction, RBX. So I just assume that they are acting vertical, the two vertical forces, reactions, and the horizontal acting in the opposite direction to that of the external load. So now to find each reaction, first of all, so I will start this calculation from summation of the forces, and the horizontal direction is equal to 0. There is only one horizontal external load acting on this frame structure, which is acting on the right column, which is 20 kg. So I can write it here that the force acting in this direction will be taken as negative, while the force acting in this direction will be taken as positive. So I can write summation of Fx is equal to 0. So Rbx, which is acting in this direction, is taken as positive, while in this direction it is taken as negative. So minus 20 is equal to 0. Summation of all forces is equal to 0. So Rbx comes out to be 20 kg. So it is only one horizontal reaction provided by the hinge support. So the 20 kg will be resisted by the horizontal reaction at the point B. So Rbx is equal to the 20 kg. Now to find the vertical reactions, I will do it by the summation method. Taking the summation of moment at point A, let's suppose that the summation of moment at point A is equal to 0. So, and let's suppose take the clockwise movement is positive. You can see the clockwise movement is positive, while the anti-clockwise taken is negative. So taking the summation of moment at point A is equal to 0. So this uniformly distributed load is 2 kg per foot is acting in the clockwise direction. You can see here it is acting in the clockwise direction at the point A. So the 2 kg per foot, so the moment will be 2 into 20 because of the uniformly distributed load. So it will be the concentrated load, and the moment arm will be 10 up to the center of the beam. So it will be 10. So now the other force is 20 kg. So again the 20 kg will be acting in the anti-clockwise direction. You can see here, so it will be minus 20, and the moment arm is 5 foot. You can see here 5 foot, 5, and also this force is also acting in the anti-clockwise direction. So again minus Rby multiplied by the moment arm is 20 is equal to 0. Summation of all forces, summation of all moments at point A should be 0. So we find all the moments at point A. So by finding the Rby, so 20 Rby, so I just put this value Rby on the right side, so it will be positive, and this will be, by calculating, this will be 400 minus 20 into 500. So Rby is equal to the 300 divided by the 20, we get 15 kg. So 15 kg is the vertical direction provided by the point B, which is the hinge support in the vertical direction. Now I can find the RA in the vertical direction is by summation of forces in the vertical direction is equal to 0. So this force is taken as positive, let's suppose, and this is taken as negative. So my RA acting in the upward direction, so upward is negative, so minus RA. Similarly, this is also acting in the upward direction, minus 15, and plus this one is acting downward, plus 2 into 20, because it is uniformly load, equal to 0. So RA comes out to be, by moving this under to the right side, so we get 40 minus 15, RA comes out to be 25 kips. So RA comes out to be 25 kips. So I found out the support reactions of this frame. Now I will draw the free body diagram and will draw the shear force and bending moment of this frame. So now I will draw the free body diagram of this frame. So this is the beam. These are the two columns. The force is, the vertical reaction is 15 kip. This will be 15 kips. This will be 25 kips. You can see here 25. So this 15 kips will also be acting here, and for in equilibrium this will also act here, 15 kip. 25 kip is acting here, so for equilibrium 25 kip will act in the downward direction. Now it will be acting in the upward direction. So these are the forces, resistance, reaction forces, while the 2 kip per foot is acting and the downward direction is the external load, 2 kip per foot. And this is also the one of the horizontal load, lateral load acting on the column is 20 kips. So this is a simple free body diagram of this frame. Now I am going to draw the shear force diagram. To draw the shear force diagram, I can draw the reference line, like means to draw again the free body diagram for the shear force. So now these are the two columns, this is the beam. Now as we know, sorry, I remain with this one, and this is 20 kip, so the resistance will also be the 20 kip. So now the 20 kip force is acting in this direction. You can see here in this direction, so it will produce the shear in the box in this direction. I can draw it here. Due to this force, it will create the shear in the column, and I can represent here it is 20 kips is the shear. This is the shear force diagram, right? I'm drawing the shear force diagram for the frame. So the 20 kips load is acting in the inward direction, so I can draw the shear force diagram for this column is like in this way. This is the shear force diagram, and there is no load acting on this column, so there is no shear force diagram for this column. So now for the beam, is the load acting here is 25, so I can draw it upward, sorry, with this marker. 25 kip is acting upward, and then the uniformly distributed load is acting in the downward direction, so it will make the shear force in the downward direction, and then downward, and then with a magnitude of 15 kips. So 15 kips will be acting in the upward and the downward direction as well. So you can see here that how I draw the shear force diagram for this column, sorry, for this beam. From the free body diagram with the known reaction forces, you can easily draw the shear force diagram. Now to draw the bending moment diagram, I will again draw the reference lines. These are the beams, this is the beam, and these are the two columns. So now for the bending moment diagram, is we know that this length is 5 feet. So the load here acting is 20 kip, and 20 into 5, we can see it is 100. 20 into 5, because force is 20 and the momentum is 5. So 20 multiply 5, we get the moment at this point. So it will be 100. So it will be 100 kips foot moment here at this point. 100 kip foot moment at this point. Now there is no load to create the moment, so similar moment will be going through the column. So 100 kip foot moment also at the end of the column, at the upper end of the column. So this is the moment diagram for the bending moment diagram for the frame, but this is only for the column. Now to draw the bending moment diagram for this beam, first of all I have to know this area of this triangle, so then I can draw the bending moment diagram. So for triangle I will need this horizontal distance, which is x, unknown to us. So to find the x, I can use this formula. The 25 kip load is acting in the upward direction. You can see here 25 is acting upward direction, while the 2 kip per foot is acting downward direction. So minus 2 and 2 x, up to which point it is acting downward. So we will find and will equal to 0. So at which point it is equal to 0. So we can find this x length. So I can find out that the x comes out to be 25 divided by 2, 12.5 foot. So this distance is now 12.5 foot. So now I can find this area of triangle. How can I find? Area of triangle can be found half into height is 25 and the length is 12.5. So by calculating this value, it comes out to be 156.25. Right? So now I can draw the bending moment diagram easily for this beam, as I know the area of this triangle. So it will be like in this way. The maximum moment 156.25 up to the distance of 12.5, while the remaining distance comes out to be subtracting the 20 minus 12.5, you can get the 7.5 feet here, right? So, and again this moment will be transferred, 100 kip foot will be transferred into here in this way, 100 kip foot, because at the joint you have to transfer the moment in the frame. So joining this point and this point, we can get the bending moment diagram for the respective frame. So the maximum moment is 156.25 acting at a distance of 12.5 from the left end, and 100 kip acting at the joint. And there is no moment here. You can see zero moment because there is a roller support, so it does not support any moment. Similarly, this point we also zero moment because it does not support any moment. So this was the way how to draw, how to analyze the frame with any type of loading, just by drawing the free body diagram, and thus convert this free body diagram into the shear force and bending moment diagram the way I did. Hope you guys understand, and don't forget to subscribe my channel for daily civil engineering videos. Thank you for watching my video.